Good afternoon. Welcome to the first class in our second semester of Introductory Physics. I always call it Fun with Physics. I'd like to thank you for attending today's lecture. Right now, I am in Canada or the United States attending the annual Physics Society meeting. Just a reminder, as we discuss in today's discussion, I'd like to present the menu first. First, we'll discuss our prerequisite. Then I'll discuss a little bit of myself, the facilitator. I'll introduce the textbook again, and discuss the websites that are important for us, the class and the homework website. I will then provide a short overview of the course, discuss the grading, and then introduce the pre-test that we'll be having, and finally discuss our next class, the first class on Friday, March 6th, which will be a problem-based learning class, and finally discuss our calendar. So these will be the things we will be discussing today. First of all, the prerequisite. This is the second course in physics. So the prerequisite for this course is last semester's EO 101. The marking this semester will also be very similar to the way in which we presented the marking last semester. Okay. Now, let's move on to the second issue in our menu today, and that's introducing myself, the facilitator of this course. Okay, my name is Jonathan David White, or Bai Xiao Ming. You can get a little bit of my background from my life story, which is at Xiao2, White JD. You will be able to find my background discussing from the very beginning up until about now. For those of you who are not aware, I am a Canadian. I did my undergraduate work at McMaster University in Hamilton, Ontario, a city very much like Taoyuan in that it was famous for strong industry, although now it is relatively poor as a lot of the factories moved to China. After graduating from university, I went to the United States, Chicago, where I studied my master's degree. After completing my master's, I returned to Canada and studied my PhD in engineering physics. In particular, I was looking at the development of high-powered lasers. Immediately after graduating, I then moved to Asia, where I spent a total of about 3 years in China, 4 years in Japan, 4 years in Malaysia, before coming to Taiwan about 10 years ago. During the course of my life, in 1997, I got married, and in 1999 we had our first child, Ian. My wife, Shouman from Nantou, and myself, then had 3 more children, Yoan, Lian, and finally our dearest little girl, Liang An, or Ruth Ann. So that basically introduces me. Now let's move on and look at the textbook. The textbook is the same textbook as we had last semester, Physics for Scientists and Engineers, A Strategic Approach, the 3rd edition by Randall Knight. We will be working with both the paper edition as well as using the online learning system that comes with the textbook. Last semester, you were introduced, and I think most people have already set up an account in this textbook. Okay, I'd like to now move on and discuss the websites of interest for this course. The first website is the class website. That will be at xiao2.com/teach/yzueo101.htm will allow you to access the class website. So the class website looks basically like this. From the home home page, you will be able to access some of the books, a little bit about the where our seating arrangements, the seating arrangements for tests, samples on how the grading is done, and a short, quick connection to PHET simulations, which will help us to understand topics that we are learning. In addition, you will be able to keep up to date with your mark to date by using our mark database and downloading the Access program. And you will find the outline of the course, both the first semester, in other words, part 1, and the second semester, which is basically just a continuation of the first semester's work. The other website, which is important, is where you will find the homework. And you will find that by signing in, as you did last semester, to the masteringphysics.com website. Here you will sign in and be able to complete your homework as well as do the tests and quizzes, just similarly to we did last semester. In fact, the pre-test is already set up online for you to work on, and we will have that next class. Okay, moving on, I'd now like to start to overview the course, what we will be studying in this class. Okay. Here is our lecture outline from our home page. Okay, in the first semester, you can see we studied first the kinematics. We learned how to understand one-dimensional motion, vectors and coordinate systems. We discussed a little bit about two-dimensional motion, how we describe the motion. We then moved on and started to discuss dynamics. In other words, Newton's laws. The idea about why things move. So we introduced forces. We talked about one-dimensional motion. We discussed Newton's third law. We discussed two-dimensional motion. After completing this basic Newton's laws perspective of dynamics, we then moved on and looked at a different way of looking at dynamics and motion. In other words, understanding motion in terms of momentum and energy. We discussed the idea of impulse and momentum. We discussed the idea of energy. We discussed the idea of work. Following that, we then started to move on. That was in linear motion. We then discussed, okay, what about when objects are rotating and oscillating? So we moved into rotations of rigid bodies. So in the first section, previously in part 1, 2, and 3, we had been assuming that our object was just a point. Then in part 4, we started to see, well, actually a real object has size. And so it's going to have a center of mass, and it's going to be able to rotate. There's going to be energy involved in its rotation. And then after we started to describe rotations, we then moved on and tried to think about oscillations. When oscillations then allowed us to finally move into the our fifth part of the class, which discussed wave motion. We discussed traveling waves, the superposition of waves. We talked a little bit about optical waves. Then we discussed how when the size of the feature size is much larger than a wavelength, how we can often use a ray approximation to help us to simplify our calculations a little bit and get a general idea of the answer. We then moved on to the idea. We then discussed a few optical instruments such as microscopes and telescopes. In this second semester, we now move on and start to learn a little bit more about energy. In fact, in the area of thermodynamics. So in the first semester, In Part 2, we used dynamics and Newton's laws. And in Part 3, we discussed of another perspective on dynamics, the momentum and energy. Now, we are moving on to discuss thermodynamics. Thermal, meaning heat. And so, in the previous case, we did not talk about, we talked about how work can sometimes be done and how that will be translated due to friction. We will create heat. In thermodynamics, we are now talking about how we move from heat back to usable energy. How can we use heat to do work? So in the previous section, we just talked about work, and then heat was a loss mechanism. Now we're going to start talking about the interaction of heat and how we can move back from heat back to work. So we'll first of all have a problem-based learning lab. We will then discuss a macroscopic description of matter, and then we'll start to move into the heat and the first law of thermodynamics. We'll discuss the relationship between the micro world and the macro world, the micro being the atoms and molecules, the macro world being what you can see and touch, with the final goal to discuss heat engines and the idea of entropy and enthalpy. The seventh part of our course, we will move into a discussion of electrostatics. So now we're going to be starting to concentrate on electricity itself. We'll start off with a discussion of electric charges and forces, the electric field. We'll discuss Gauss's law, and we'll discuss electric potential. Following that, we will then have our second challenge, or our second milestone, will be an electrostatics test. We'll move on, studying electrostatics in more detail in Part 8 of our course, when we'll start to look at another viewpoint of potentials and fields. We'll discuss a little bit about current and resistance, and then finally DC circuits, following which we will have the third challenge test on electrostatics 2. After completing electrostatics, we'll move into a discussion of magnetism. In particular, we'll discuss the magnetic field for a couple of classes. This will be followed by lectures dealing with electromagnetic induction, which will then allow us to move into the idea of electromagnetic fields and waves. So we're almost like in Part 9, we're starting to move back to Part 5 again, connecting again with the idea of waves, but now we're going to work on electromagnetic waves. So in previous, we talked a little bit about the idea of water waves, waves on a string. Now we'll be discussing full electromagnetic waves, which includes optical waves. We will then have one lecture discussing AC circuits, and then finally we'll have another challenge. The fourth milestone will be discussing magnetism. If we have additional time in the class, we'll move on and discuss a little bit about quantum mechanics and modern physics. So that gives us an idea of this is the syllabus that we will be following this semester. So moving back to our menu again, probably what most people are also interested in is the grading of this course. How will we be assigning the grades? Okay, let's look at this issue now. Okay, our grading. Okay, so our mark allocation is basically as follows. Homework, in other words, the online homework you do, will be worth 15% of the class mark. The in-class work, that will include things like problem-based learning activities, etc., will be about 10% of your mark. Reading quizzes, which will be done before we study something, can give you a total of 5% of your mark. The main part of your mark will come from 4 milestone tests. Okay? The first milestone test will be on thermodynamics. The second milestone test will be on electrostatics, Part 1. The third milestone test will be electrostatics, Part 2. And the fourth milestone test will be on magnetism. We will weight these. Will be weighted. One of these will be weighted for 10%. One will be weighted as 15%. One will be weighted as 20%, and one will be weighted as 25% of these 4 milestones. And finally, which we denote as MP, there's the pre-test, which we will take, which will be next class, in which will give you an opportunity to try to see how well you have done. Okay, so I'd like to now discuss the algorithm which we will be using in calculating your marks. Okay, that's the second point here. First of all, we will order your marks for the 4 milestones from the smallest to the largest. In other words, the lowest mark to the highest mark. Okay? We will then calculate a mark MM. In other words, we'll multiply your smallest mark out of 100 by 0.1. We will add the next smallest mark times 0.15. We will add the second from the biggest mark times 0.20, and we'll multiply your biggest mark by 0.25, and then divide by 0.7 to give you a mark out of 100. We will then, based on this, we will then multiply your homework mark, MC1, which is a mark out of 100, by 0.15, that is 15%, right? We'll multiply your class mark by 0.1, 10%. We'll multiply your reading quiz mark by 0.05, 5%. And we'll also multiply your total milestone mark by 0.7. This will give you another mark out of 100. Your final mark will then be selected as the maximum of MP, which is the pretest mark, all the marks mixed together, M all, or just your milestone marks. So whichever is highest. So let's take a couple of examples of how we would do the specific students here. I've got 4 students here. The first one is Da Ming. He basically didn't show up for any classes, didn't write any milestones, but got 95% on the pretest. I have Susan, a hard-working student. She got 100% on the homework. She was very faithful in attending classes and got 100% there, and did very well in the reading quizzes, got 100% there. However, in milestones, she didn't do quite as well, and her pretest was very poor. Our third student is Jimmy. Well, he did about 25% of his homework, but basically he's sort of lazy guy. He didn't attend class that much. He didn't bother doing the reading quizzes, and he didn't do most of the homework. However, he seemed to prepare fairly well for the test, getting 80% on the first one, 50% on the second, 40% on the third one, and 90% on the last magnetism test. His pretest mark was only about 20% though. Okay, so these 3 examples, let's look at how we would get their marks. Okay, let's consider first of all Da Ming. Okay, as you can see here, his milestone marks add up to 0. All the marks together add up to 0, but his MP equals 95%, his pretest. So his final mark will be 95%. He will get the pretest mark. Now for Susan, she's more complicated. So our first step is we order the milestone marks from smallest to largest. So 20, 30, 50, 60. We then calculate MM, and by multiplying the lowest mark by 0.1, the next one by lowest one by 0.15, 0.2, 0.25, and then dividing by 0.7. So we get a mark 46 out of 100. Okay. Hit her all marks. We then multiply 0.15 times 100, because 0.1 times 100, 0.05 times 100, and then 0.7 times her 46. So the M all, if we include everything in terms of her classwork as well as the milestone, she gets 62. So, since her pretest is small, the highest mark of these 3, 46, 62, and the pretest mark of 10%, her final mark will be 62%. Okay, the highest of those 3. The final is the maximum of those ones. Our third student is Jimmy. Again, let's order the milestone marks. So 40, 50, 80, 90 from smallest to largest. We then calculate MM, which gives us 71% out of 100. We calculate MAll, which gives us 54 out of 100 because he did not do very well in his class mark. When we bring that in, it lowers his marks, so it's dropped down to 54. So, of the 3 then, his final mark will be 54%, since his pre-test mark was also 20%. So his final mark will be given the maximum of those, which is 71. So he will receive 71% as his final mark. Now, if you want to see how these calculations work, here is an example spreadsheet to show you. You can then work on it, and you can see how the marks for Susan, for Jimmy, how we will enter into marks for each of them for the 3 components of your classroom work, as well as the milestones, and then finally how we do the final calculations of MM, MAll, and MP, and get the final results being, you can see of these 3 marks, MP here is highest, so he got his highest was MAll, this person's highest is, Jimmy's highest is the final is the maximum of these guys too, which gives us the maximum mark. Okay, so now I've looked through the prerequisite. I hope you've completed EO 101 and you've now bought the textbook. I'm the facilitator, Jonathan White. I will be back in Taiwan in March. You have the class website, the homework website. I've overviewed the course, which you can always find online. The grading is online too. Now, the pre-test. There will be a pre-test. Chen Kao will be in the computer lab this Thursday, March 5th from 8 o'clock to 10 o'clock. So if you do very well on this pre-test, it can be used as your final mark. If you do, the first class in problem-based learning will also be in the computer lab. It will be on Friday, March 6th, 13 to 1500. Now, the final thing I want to discuss is the calendar. You can find my calendar at xiao2.com, calendar.htm. So you can go to my calendar, and basically see what I'm doing. So as you can see here in my calendar, I'm now currently at the APS meeting in March. Okay, and you can see when I have time and when my office hours are. For example, on March 12th, I will have an office hour from 12 o'clock. I will then have from 12 to 1 o'clock. I have another office hour from 5 o'clock to 6 o'clock. And you can also see my different class schedules when we have our physics classes, when we have our research meeting for my group research meetings. These you can all see by just coming to my onto my website. So in conclusion, I would like to thank you for taking this class, and I hope that we can have an enjoyable time together studying through. Remember, our website is at xiao2.com, so we can at our main page at xiao2.com, and you can find information about myself, etc. here. Thank you, and I hope you have a good day.